My name is Hamad Ahmed, and I am a teacher of physics. This is my first video I'm going to make on Loom. This will be an experience. Let's see what happens. I am going to start the first lesson of physics of F.Sc. Part 1, and this chapter is all about the measurements and physical quantities. So I have made a very simple first presentation about the physical quantities and units. You can see on the screen. Let's see what we'll study in this lesson today. The learning objectives of the lesson today will be at the end of the lesson, students will be able to describe what is a physical quantity. There are so many physical quantities we deal with in this world in our daily life. So today we'll have to understand what is the meaning of a physical quantity. Then what are the types of those physical quantities? What are their units in which we measure them, and what are their examples? Then there is a very important system, international of units, uh, and the international system, and it has some bases, very important bases. We have to understand this system as well, because almost all the nations of the world adopt this system, so that there is homogeneity in understanding a physical quantity throughout the world. Let's start the lesson. First we have to understand what is the meaning of a physical quantity. So you people have to first remember its definition, a very simple definition. A physical quantity is a quantity that can be measured. We can measure a physical quantity. We can use a tool, an instrument to measure the physical quantity. For example, force is a physical quantity, we can measure it. We can use a Newton meter, force meter to measure force. Mass is a physical quantity, we can use an electronic balance to measure the mass of an object. Pressure, for example, atmospheric pressure can be measured using a barometer. Temperature of any object, let's say the temperature of human body can also be measured, and we use thermometer to measure the temperature. So these are some examples of the physical quantities. Obviously these can be measured. Now, uh, these physical quantities are often divided into two following types. It means physical quantities have two main types. Number one is the base physical quantities, and the second one is the derived physical quantities. It means physical quantities have two main types, and they're on your screen. You can clearly see base physical quantities and derived physical quantities. We will look at these quantities one by one in their turn. Now, what is a base physical quantity? It's a very simple thing to understand. A base physical quantity basically is independent of all other physical quantities. We need no other physical quantity to describe, to explain a base physical quantity. It has its own sense. It is not dependent upon other quantities. For example, length. Length, you can take length as distance from one point to another, one position to another. Distance or length does not depend on any other quantity. If you want to measure the distance of a room, you can use a measuring tape. You want to measure the distance of a book, you can use simply a scale, etc. It is not dependent on any other quantity. Similarly, time is a base physical quantity. It is not dependent upon any other quantity. You want to measure time, for an interval, for an event to take place, uh, you can use your wristwatch, you can use wall clock, you can use stopwatch. The the measurement of time is not dependent upon any other quantity. Similar is the case of the mass. So I have given three examples of base physical quantities. There are more examples. So the thing to understand is the base physical quantity is defined not depending upon any other physical quantities. Now, there is a very important other thing as well. These base physical quantities are the minimum number of quantities which are used to describe other quantities. It means we will use the base physical quantities to describe other quantities. Those other quantities are known as the derived physical quantities. It means whenever we want to describe a derived physical quantity, whenever we want to make a derived physical quantity, we need other base quantities. If we don't have base quantities, we cannot make a derived quantity. For example, a very simple example. I have given three examples, but we take the first one, the simplest one, speed. Speed is a derived physical quantity. In order to explain this quantity speed, we need two other quantities. If we don't have those two quantities, we cannot explain speed. We cannot understand speed. And what are those physical quantities required to explain speed? It is on your screen. You can clearly see the equation of speed is distance over time. It means if we do not have distance but we have time, we cannot measure speed. On the other hand, if we have the value of time but we do not know the distance covered, we cannot measure speed. So speed is a derived quantity which depends upon these two quantities, distance and time. We need these two quantities. Distance is a base quantity, time is a base quantity, and we have to use these two base quantities, distance and time, to explain speed, to find speed, to describe speed. So any quantity which is dependent upon other quantities is known as a derived physical quantity. Same is the case with power, same is the case with work, same is the case with force. These all quantities that I have named are all derived physical quantities. They are dependent on other quantities. They cannot be measured directly. They have to be dependent upon other quantities, maybe base physical quantities. Now, we move a little bit forward to understand what is the international system of units. Uh, Basically, an international committee, an international conference of scientists, uh, has agreed on a set of definitions and standards for the physical quantities. They have given the names to the physical quantities. They have given the units to those physical quantities. They have given the values to those physical quantities, the standard values. For example, if we talk about length, and we know that length's unit is meter. So what is 1 meter equal to? What is the length 1 meter equal to? They have made length 1 meter practically, physically, and they have placed it over there. Every nation, almost every nation, every country of the world uses that standard of length and its unit meter, and so on and so on. So the system international has been designed for almost all the countries in the world, so that there is homogeneity, there is harmony between the values that we measure, so that when we send something from one country to another country, and if we have, let's say, send uh, uh, an object of having mass 50 kg, it must be understood and taken as 50 kg in that country as well. It must not be considered in pounds or any other units, because kg is the international unit for the measurement of the mass. So this is the uh, necessity of the time to have an international system of units. Now, this system international is built upon three kinds of units, and those are: number one, base units, then supplementary units, and then we have the derived units. It means this system international is composed of these three units: base, supplementary, and derived. We have to see these three units individually. So first we start studying and understanding what is the meaning of a base unit. Obviously, base unit is the unit of a base physical quantity, and we have already seen that a base physical quantity is independent of all the other physical quantities. And please keep in mind there are only seven base units in the world. Seven base units that have been decided as yet. And what are those seven base units? This is a table which is showing you the names of all the physical quantities which are base, their SI units, and their symbols. For example, length is a base physical quantity. Its SI unit is meter and its symbol is m, small m. Mass is a base physical quantity. Is its SI unit is kilogram and its symbol is small kg. Time is a base physical quantity. Its SI unit is second and its symbol is small s. Similarly, we have all other units. These are all seven, and there is no other unit known as base units which is not given in this table. Any unit which is not given in this table will not be named as a base unit. Base units are only seven. You have to remember these seven base units by heart, their symbols, their units, and everything which is given in this table. It is really very important. Now, we now talk about the supplementary units. Basically, there are two units right now in the world which have not been decided by the scientists whether they are base units or derived units. They haven't been named as base units, they haven't been named as derived units. So, these units which have not been uh, named base or derived, they are named as supplementary units. And what are those two supplementary units? Given in the table, you can clearly see the physical quantity for the supplementary unit is plane angle, and the supplementary unit is radian, RAD. And the second supplementary uh, physical quantity is solid angle, and the supplementary unit for this quantity is sterdian, and its symbol is SR. These are two supplementary units. Scientists have not yet classified and decided whether these two units are base units, whether these two quantities are base physical quantities, or they are derived physical quantities and units. This is why they have been named as supplementary physical quantities and supplementary units. You have to remember these two names, these are very simple, but their definition and their a little explanation is also important. So we look into these two units one by one. First, we try to understand what is radian. You have to see its definition. It's very simple. What is radian? In order to understand the definition of radian, we will use this diagram. uh, you people can clearly see there is a circle, and you know what is the circumference of the circle. Circumference is basically the perimeter of all this circle. And you know one thing more which is very easy, that if we start from the center of the circle and we move towards the end, this is the radius of the circle. In this circle, two radii have been drawn. There is this radius from this point till this point. Then there is another radius which is drawn from this point up to this point. When we draw these two radii, this radius and this radius, then we can see there is an arc. This is an arc. An arc is made whenever we draw two radii in a circle. And when we do all these things, you can clearly see there is an angle. There is an angle between these two radii. This angle, this angle is measured in radians. The SI unit for the angle is radian, and this angle will be exactly equal to 1 radian if this arc length is equal to the radius. It means whenever we make whenever we make two radii in a circle, there is an angle subtended at the center. This angle will be equal to exactly 1 radian if this arc length is exactly equal to the radius. So this is very important. You have to understand this thing. Radian is obviously the unit of the plane angle. Keep in mind, uh, some students think that the unit of angle is degree. Degree is not the SI unit of angle. Keep in mind, please, as physical quantities have more than one units. For example, temperature has three units: Kelvin, degree Celsius, and Fahrenheit. But you know that SI unit is of the Kelvin is of the temperature is Kelvin. Similarly, the SI unit for the plane angle is radian. And what is 1 radian equal to? It is very clearly given in this slide. Go through this slide very carefully. Listen to what I have told you again and again, and you will inshallah understand what is the meaning of radian. Now, we move to the second supplementary unit, which is sterdian. And what is sterdian? Oh, yes, yes. Sterdian is the solid angle in three dimension. Okay, three dimension. It means when we were dealing with this radian, this was in the circle. It was a plane angle and it was in two dimensions. A circle is always drawn in two dimensions. This is why its angle is plane angle. It is always in two dimensions. So when we move towards the sterdian will be dealing with the solid angle, and that solid angle is in three dimensions. Now, how will we understand what is the sterdian equal to? In order to understand, we have to see this diagram. It is very simple. Just see just see the definition. I read it with you. The sterdian is the solid angle. Solid angle means this will be the angle. It's not drawn here, but the angle over here. The angle over here. Subtended at the center, obviously. This is the center of the sphere. And what is the condition? The condition is this surface area must be equal to the square of the radius. Just see, boys, the students maybe, girls and boys. So just look at it very carefully, that sterdian is the solid angle, and it is obviously made at the center of the sphere, and it will be made when at least two radii have been drawn. It will be between these two radii. This angle will be sterdian, and it will be sterdian when the area over here is exactly equal to the square of the radius of the sphere. This is the difference between sterdian and the radian. Radian was the plane angle, sterdian is the solid angle. Radian was made in a circle in two dimensions. Sterdian is made in a sphere which is in three dimensions. In the case of the radian, the radius of the circle must be equal to the arc length. Actually, arc length must be equal to the radius of the circle. And in the case of sterdian, the area, this area must be equal to the square of the radius. Please keep in mind the difference between these two things. Now, we move towards the third type of units, derived units, which are in the System International. System International comprises of this type of units as well. And what is a derived unit? Obviously, you know very well. I have told you before that in System International there are some physical quantities which are dependent upon other physical quantities. Their units are also dependent on the other uh, units. The units of derived quantities may be dependent upon the units of base quantities or on the units of the supplementary quantities. So there is a very simple table. You can clearly see some physical quantities are given: force, work, power, pressure, electric charge, and you can see their SI units: Newton, Joule, Watt, Pascal, Coulomb. You can see their symbols. The symbol for Newton is capital N, symbol for Joule is capital J, symbol for Watt is W capital, Pascal is represented by PA, Coulomb by capital C. But now look at the last column of this table. Its heading is in terms of base units. You can very clearly see Newton is equal to kg meter per second square. Basically, the unit of force Newton has been broken down into its base units. We will later on see how do we break down an SI unit into its base units. But for the time being, right now, just look at it very carefully. Kg is a base unit of mass. Meter is a base unit of length. Second is the base unit of time. It means this unit Newton, which is of a physical quantity force, which is a derived physical quantity, it is dependent upon three base units: kg, meter, and second. Similarly, the derived unit joule is dependent upon kg, meter, second. Watt is dependent upon kg, meter, second. Pascal dependent upon kg, meter, second. And lastly, in this table, Coulomb is dependent upon ampere and second. All the units, ampere, second, kg, meter, and second, all these units are base units which are used to make the derived units like Newton, Joule, Watt, Pascal, and Coulomb. So, dear students, this is what I wanted to talk to you today, discuss to you today about physical quantities and units. This is my first video, and let's see, I make other videos for you people to understand physics. Thank you very much. Please go through these slides and video carefully, and if you have any questions, we'll see what we can do for you. Thank you very much. Allah Hafiz.